Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve this question on electrochemistry as on the board. And the question is as follows. The standard oxidation potential of zinc is 0.76 volts and that of silver is minus 0.80 volts. Calculate the EMF of the cell at 25 degrees Celsius. So this is the EMF of the cell. It consists of zinc dipped in zinc nitrate and silver dipped in silver nitrate. Now, for us to find the EMF of the cell, we need to first of all be able to write the overall reaction or equation for the cell. And that requires us to know which of these half cells is the anode and which one is the cathode, and where does oxidation take place and where does reduction take place. Now, looking at this galvanic cell, zinc dipped in zinc nitrate represents the anode half cell, and silver dipped in silver nitrate represents the cathode half cell. So, at the anode, the equation is that zinc loses electrons to give Zn2 plus, and we've been given the oxidation potential of zinc to be 0.76 volts. Also, don't forget that in the galvanic cell, oxidation takes place at the anode. So, the oxidation potential for the zinc half cell is 0.76 volts. And then, the silver half cell is where reduction takes place, that's the cathode. So, at the cathode, you have silver ion accepting electrons to give silver. Now, we are given the oxidation potential of silver. But what takes place in the silver half cell, which is at the cathode, is reduction. So to convert that oxidation potential to reduction potential, we simply change the sign. So it's no longer going to be minus 0.80 volts. It will become plus. So the reduction potential for the silver half cell is going to become plus 0.80 volts. Now, to ensure that the number of electrons are the same, we will multiply the equation at the cathode by 2. Now, after doing this, after multiplying it by 2, we can now write the overall cell reaction, which is going to be zinc plus 2Ag plus, the electrons will cancel out each other, and then you have Zn2 plus Ag. So we have to calculate the standard cell potential, that's the E0 cell. Now we have the oxidation potential of the anode and the reduction potential of the cathode. So to find the standard cell potential, it is simply going to be the oxidation potential of the anode, which is 0.76 volts, plus the reduction potential of the cathode. So when these two are added together, you get 1.56 volts. So we have E0 cell. But this is not what the question is telling us to find. The question wants us to find the EMF of the cell, which is E cell. So using Nernst equation, shouldn't forget that E cell is going to be equal to E0 cell minus 0.0591 divided by 2 log K. K in this case is the equilibrium constant or the reaction quotient, and it is actually equal to the concentration of the ion in the product over the concentration of the ion in the reactant. Now, how do we get which one is the product and the reactant? We have to look at the overall cell equation, which is this. Now, looking at the overall cell equation, you can see that Zn2 plus is the ion in the product and Ag plus is the ion in the reactant. So this means that E cell is going to become E0 cell minus 0.0591 divided by 2 log concentration of Zn2 plus over concentration of Ag plus raised to power 2. We're raising to power 2 because of the 2 that is in front of it here. Now, the next thing is to impute the values. The concentration of Zn2 plus is the same as the concentration of zinc nitrate because zinc ion is present in zinc nitrate. So the concentration of Zn2 plus is 0.25 mole per dm cube. And the concentration of Ag plus is the same as the concentration of silver nitrate because Ag plus is present in silver nitrate. So the concentration of Ag plus will simply be 0.1 mole per dm cube. So imputing these values, you have that your E cell is simply going to become E naught cell, which is 1.56 minus 0.0591 divided by 2 log. For this, it is going to be 0.25 over 0.1 raised to power 2. And then E cell is going to be equal to 1.56 minus 0.02955 log 0.25 divided by 0.1 squared. Now, when this is simplified, and you divide this by this and find the log, and then you simplify this, the value of the EMF of the cell is going to be 1.5187 volts. And this is the answer to the question. So I want to believe that the explanation to how this question is solved is clear. Thank you very much for watching. See you in the next lesson.